Brief power interruptions, sometimes called power flickers, are indeed a common occurrence. These events, lasting less than a second, can cause digital devices to blink and reset, which can be disruptive. There are several factors that can cause these power flickers. Firstly, switching of capacitor banks is a common cause. Utilities use capacitor banks to improve the efficiency of power transmission. Periodically, these banks are switched on or off to adjust to changing load conditions. This switching can create brief voltage fluctuations that manifest as power flickers. Secondly, the switching of transformers can also cause power flickers. Similar to capacitor banks, transformers are sometimes switched to optimize the power grid. This switching process can momentarily interrupt the power flow. Thirdly, faults in the power system, such as a tree branch touching a power line or equipment malfunction, can trigger protective devices to rapidly interrupt and restore power, leading to flickers. Finally, lightning strikes, even those that don't directly hit your property, can induce voltage surges and dips in the power grid, resulting in brief power interruptions. In most cases, power flickers are harmless and don't damage electronic devices. However, frequent or severe flickers could potentially shorten the lifespan of sensitive equipment. To protect your devices, consider the following measures. 1. Using surge protectors is a good starting point. Surge protectors can absorb voltage spikes and surges that may occur during a power flicker, preventing them from reaching your electronic devices. 2. Investing in uninterruptible power supplies, or UPS, is another effective strategy. A UPS provides backup power to your devices during a power outage or flicker, ensuring that they continue to operate without interruption. While a UPS won't prevent the flicker itself, it will prevent your devices from experiencing the effects of the flicker. 3. For sensitive equipment like computers or medical devices, consider using a line conditioner. Line conditioners regulate the voltage and filter out noise from the power supply, providing a more stable and reliable power source. 4. Ensure your home's wiring is up to code and in good condition. Loose connections or outdated wiring can exacerbate the effects of power flickers. 5. If you experience frequent power flickers, report them to your utility company. While there might not be a real-time system to track flickers in your area, reporting the issue can help the utility identify and address any underlying problems on their end. When reporting a power flicker to your utility company, provide them with as much detail as possible. This includes the date, time, and duration of the flicker, as well as any specific devices that were affected. The more information you provide, the better equipped the utility will be to investigate the issue. It's also helpful to note whether your neighbors are experiencing similar problems. This can help the utility determine whether the issue is localized to your property or is more widespread. Be prepared to answer questions about your home's electrical system, such as the age of the wiring, the type of appliances you use, and any recent electrical work that has been done. The utility may also want to send a technician to your home to inspect your electrical system. If you're concerned about the potential impact of power flickers on your electronic devices, consider consulting with a qualified electrician. An electrician can assess your home's electrical system and recommend appropriate measures to protect your devices. They can also help you identify any potential problems with your wiring or appliances that may be contributing to the flickers. Remember, power flickers are a common phenomenon, but they don't have to be a major inconvenience. By understanding the causes of flickers and taking steps to protect your devices, you can minimize their impact on your home and your electronic equipment. The causes can be difficult to pinpoint without the proper equipment. A power quality analyzer could be connected at the point of service to monitor and record voltage variations, transients, and other power disturbances over a period of time. This data can then be analyzed to identify the source and nature of the power flickers. Utilities often have specialized equipment for identifying the source of voltage fluctuations in their system. They can use this equipment to determine if the problem is originating from their equipment or within your own electrical system. Power flickers can be a nuisance, but they are usually not a sign of a serious problem. By understanding the causes and taking steps to protect your devices, you can minimize their impact on your home. If you're concerned about the potential impact of power flickers on your electronic devices, consider consulting with a qualified electrician. An electrician can assess your home's electrical system and recommend appropriate measures to protect your devices. They can also help you identify any potential problems with your wiring or appliances that may be contributing to the flickers. Understanding power flickers requires understanding some aspects of electrical power systems. Power is transmitted over long distances at high voltages to reduce losses. These high voltages are then stepped down at substations using transformers before being distributed to homes and businesses. The distribution system is a complex network of wires, transformers, and protective devices designed to deliver reliable power. However, this system is also susceptible to disturbances that can cause power flickers. For example, when a large motor starts, it can draw a significant amount of current, causing a temporary voltage drop. This voltage drop can manifest as a power flicker. Similarly, when a large load is switched on or off, it can cause a sudden change in the voltage, leading to a flicker. In addition to these operational factors, power flickers can also be caused by environmental factors such as lightning strikes and weather conditions. Lightning strikes can induce voltage surges and dips in the power grid, while high winds can cause power lines to sway and make contact with each other, leading to brief interruptions. It's important to note that power flickers are not always a sign of a problem with the utilities equipment. They can also be caused by problems within your own home's electrical system. For example, a loose connection in your wiring can cause a voltage drop that manifests as a flicker. Similarly, an overloaded circuit can cause the voltage to sag, leading to a flicker. If you experience frequent power flickers, it's important to have your home's electrical system inspected by a qualified electrician. An electrician can identify any potential problems and recommend appropriate repairs. In addition to protecting your devices from power flickers, it's also important to protect yourself from electrical hazards. Always follow safe electrical practices when working with electricity. Never touch bare wires or electrical components, and always turn off the power before working on any electrical equipment. If you're not comfortable working with electricity, hire a qualified electrician to do the work for you. Power flickers can be a nuisance, but they don't have to be a major problem. By understanding the causes of flickers and taking steps to protect your devices and yourself, you can minimize their impact on your home and your life. Remember to report any frequent or severe power flickers to your utility company. They may be able to identify and address any underlying problems on their end. Power companies are very interested to know if there is any disturbance of power, because they have certain service level agreements and key performance indicators to meet. So the public should be reporting any deviations of power so that the utility company can work to meet these important benchmarks. The equipment used to monitor the power system, perform switching operations, and respond to faults is constantly being upgraded. This is an ongoing process that is essential for maintaining a reliable power supply. Some common equipment are capacitor banks, transformers, circuit breakers, relays, and monitoring systems. Understanding how these components work together can help you better understand the causes and consequences of power flickers. Capacitor banks are used to improve the power factor of the system. The power factor is a measure of how efficiently electrical power is being used. A low power factor can lead to increased losses and reduced system capacity. Capacitor banks help to correct the power factor by providing reactive power to the system. Transformers are used to step up or step down the voltage of the power system. They are essential for transmitting power over long distances and for distributing power to homes and businesses. Circuit breakers are used to protect the power system from faults. When a fault occurs, the circuit breaker will automatically trip, interrupting the flow of current and preventing damage to equipment. Relays are used to detect faults and to initiate the tripping of circuit breakers. They are an important part of the protection system. Monitoring systems are used to monitor the performance of the power system. These systems can provide real-time data on voltage, current, and other parameters. This data can be used to identify potential problems and to take corrective action. All of these components work together to ensure a reliable and efficient power supply. Power flickers are a relatively common occurrence, but they can be disruptive. By understanding the causes of flickers and taking steps to protect your devices, you can minimize their impact on your home. A more detailed discussion of the factors that contribute to power flickers can involve the specifics of power system protection schemes and equipment maintenance practices. Power system protection is designed to quickly isolate faults on the system to minimize the impact on customers. When a fault occurs, protective relays detect the fault and send a signal to a circuit breaker to trip, interrupting the flow of current. The speed at which the circuit breaker trips is critical for minimizing the duration of the power flicker. Utilities have specific maintenance practices in place to ensure that their equipment is operating properly. These practices include regular inspections, testing, and repairs. Proper maintenance can help to prevent faults from occurring and can reduce the likelihood of power flickers. Power quality issues are a growing concern for many homeowners and businesses. As more and more sensitive electronic equipment is being used, the impact of power quality disturbances is becoming more pronounced. Power flickers are just one type of power quality disturbance. Other common disturbances include voltage sags, voltage swells, and harmonics. Voltage sags are a temporary decrease in the voltage. They can be caused by a variety of factors, such as starting a large motor or switching on a heavy load. Voltage swells are a temporary increase in the voltage. They can be caused by factors such as lightning strikes while switching off a large load. Harmonics are distortions of the voltage and current waveforms. They can be caused by nonlinear loads, such as electronic devices and variable speed drives. Power quality disturbances can have a variety of negative impacts on electronic equipment. They can cause equipment to malfunction, to fail prematurely, or to operate less efficiently. In some cases, power quality disturbances can even pose a safety hazard. There are a number of steps that can be taken to mitigate the impact of power quality disturbances. These steps include using surge protectors, installing uninterruptible power supplies or UPS, and filtering the power supply. Surge protectors can protect equipment from voltage spikes and surges. UPS can provide backup power during power outages or voltage sags. Filters can remove harmonics from the power supply. For critical applications, it may be necessary to install a power conditioning system. Power conditioning systems are designed to provide a clean and stable power supply. They can correct for voltage sags, voltage swells, harmonics, and other power quality disturbances. The cost of a power conditioning system can vary depending on the size and complexity of the system. However, the cost can be justified for critical applications where reliable power is essential. Power quality is an important issue for all homeowners and businesses. By understanding the causes of power quality disturbances and taking steps to mitigate their impact, you can protect your electronic equipment and ensure reliable power. Utilities may also make improvements to the grid to proactively address the issue. These improvements include upgrading equipment, implementing new technologies, and improving maintenance practices. One common upgrade is replacing older circuit breakers with newer, faster-acting circuit breakers. This can reduce the duration of power flickers caused by faults in the system. Another common upgrade is installing automatic voltage regulators or AVR at substations. AVR can maintain a stable voltage level, even when there are fluctuations in the load. Utilities are also exploring the use of new technologies, such as smart grids, to improve power quality. Smart grids use advanced sensors and communications to monitor and control the power system in real time. This can help to identify and address power quality problems more quickly and efficiently. In addition to these technical improvements, utilities are also improving their maintenance practices. Regular inspections and testing of equipment can help to prevent faults from occurring. Proper maintenance can also help to extend the life of equipment and reduce the risk of power outages. Power quality is a complex issue, but it is an important one. By working together, utilities, homeowners, and businesses can improve power quality and ensure a reliable power supply. Always follow the manufacturer's instructions when using any electrical equipment. Do not overload circuits or extension cords. Be sure to use the correct type of extension cord for the application. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Keep electrical equipment away from water. Never use electrical equipment in wet or damp locations. Do not attempt to repair electrical equipment yourself. Hire a qualified electrician to do the work for you. Always turn off the power before working on any electrical equipment. The National Electrical Code or NEC provides detailed requirements for the safe installation of electrical wiring and equipment. It is important to follow the NEC when working with electricity. Article 210 covers branch circuits. Article 215 covers feeders. Article 230 covers services. Article 250 covers grounding and bonding. Article 300 covers wiring methods. Article 310 covers conductors for general wiring. Article 400 covers flexible cords and cables. Article 406 covers receptacles, cord connectors, and attachment plugs or cord sets. Article 408 covers switchboards, switchgear, and panel boards. Article 430 covers motors, motor circuits, and controllers. Article 440 covers air conditioning and refrigerating equipment. Article 500 covers hazardous location. Article 501 covers Class I locations. Article 502 covers Class Roman II locations. Article 503 covers Class Roman III locations. Article 504 covers intrinsically safe systems. Article 505 covers Zone 0, Zone 1, and Zone 2 locations. Article 510 covers hazardous or classified locations specific. Article 511 covers commercial garages, repair and storage. Article 513 covers aircraft hangars. Article 514 covers motor fuel dispensing facilities. Article 515 covers bulk storage plants. Article 516 covers spray application, dipping, and coating processes. Article 517 covers healthcare facilities. Article 518 covers places of assembly. Article 520 covers theaters, audience areas of motion picture and television studios, and similar locations. Article 525 covers carnival, fairs, and similar events. Article 530 covers motion picture and television studios and similar locations. Article 540 covers motion picture projection rooms. Article 547 covers agricultural buildings. Article 550 covers mobile homes, manufactured homes, and mobile home parks. Article 551 covers recreational vehicles and recreational vehicle parks. Article 552 covers park trailers. Article 600 covers electric signs and outline lighting. Article 604 covers manufactured wiring systems. Article 605 covers office furnishings. Article 610 covers cranes and hoists. Article 620 covers elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. Article 625 covers electric vehicle charging systems. Article 626 covers inter-system bonding terminations. Article 630 covers electric welders. Article 640 covers audio signal processing, amplification, and reproduction equipment. Article 645 covers information technology equipment. Article 646 covers modular data centers. Article 647 covers sensitive electronic equipment. Article 650 covers pipe organs. Article 660 covers X-ray equipment. Article 665 covers induction and dielectric heating equipment. Article 668 covers electrolytic cells. Article 669 covers electroplating. Article 670 covers industrial machinery. Article 675 covers electrically driven or controlled irrigation machines and equipment. Article 680 covers swimming pools, fountains, and similar installations. Article 682 covers natural and artificially made bodies of water. Article 690 covers solar photovoltaic systems. Article 691 covers large-scale photovoltaic or PV power production facility electric power systems. Article 692 covers fuel cell systems. Article 694 covers wind electric systems. Article 695 covers fire pumps. Article 700 covers emergency systems. Article 701 covers legally required standby systems. Article 702 covers optional standby systems. Article 705 covers interconnected electric power production sources. Article 708 covers critical operations power systems or COPS. Article 720 covers circuits and equipment operating at less than 50 volts. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Article 750 covers energy management systems. Article 760 covers fire alarm systems. Article 770 covers optical fiber cables and racewires. Article 800 covers communications circuits. Article 805 covers communication systems. Article 810 covers radio and television equipment. Article 820 covers community antenna television and radio distribution systems. Article 830 covers network-powered broadband communications systems. Article 840 covers premises-powered broadband communications systems. Article 900 covers tables and examples. It is important to note that the NEC is not a design manual. It provides minimum safety requirements for electrical installations. It is the responsibility of the designer to ensure that the electrical system is adequate for the intended use. Also, Table 310.15b16 provides ampacities for insulated conductors rated up to and including 2000 volts with not more than 3 current-carrying conductors in raceway or cable or earth based on ambient temperature of 30 degrees Celsius and applies to 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius insulated conductors.